Welcome back, and we are together, Mama H and you, and that means it's life sciences. And of course, we are looking at population ecology, and we're looking at how to do data response questions in this particular section. So let's look at what we mean by the data response question. Remember, reading the question is essential, and then reading or studying the resources. Reread the question. Be very certain of what you are being asked to do. And then you start answering each part of the question. Mark allocation will give you an idea of how much information is required. If you're asked to interpret, you have to analyze and explain data, and very important, drawing tables and the different kinds of graphs. These are hugely important skills that you need to know to answer data response questions. So let's give one a try, shall we? This first one is one that gives us lots of text in the beginning, a lot to read through. Use your pen or your highlighter to underline the important things. A learner performed the following investigation. She wanted to find out if plant seedlings that are crowded would grow as tall as seedlings planted with adequate space between them. So what did she do? She placed the same amounts of identical soil in two identical pots, and she labeled them pot A and pot B. Into pot A, she planted 40 radish seeds, and she made sure they were equally spaced apart. Into pot B, she only planted 5. Right, so there's a difference. She also spaced them equally apart. She placed the pots on a warm windowsill. She watered them both every day with the identical amount of water. And after 2 days, the seeds in both pots began to germinate. What did she do? She measured the average height of the seeds every day, and she recorded her measurements. Here is the table. Day 1, after germination, we see that pot A has an average seedling height of 2 millimeters. In that pot, in day 2, they had grown to 10 millimeters, 12, all the way up to 22 millimeters on day 8. In the meantime, what was happening in pot B? Well, also starting at 2 millimeters, for the first day, 11, 15, 22, just have a look at that interesting point, all the way up to 78 millimeters. So just looking at the data table, we can see that there is a difference in the way these plants in the two different pots are growing. Remember, they're the same kind of plant. They're getting the same amount of resources. The only difference is we've got crowding in one pot, in other words, a high population density, and we've got a low population density or adequate spacing in the other pot. So we can see that certainly we've got a difference in terms of the growth. But to get a better picture of what the trend is in terms of this difference, let's look at our first question. Draw a graph to illustrate this data. Now, I want to ask you, please, if you are writing your test and you've got about 5 lines at the bottom of the page, don't try and squash your graph into that small amount of space. Make the graph large over a full page, if possible, so that you've got space to draw, so that it's easy for your marker to read and mark, and it's easy for you to plot the points. So we start off drawing our graph with two axes, the y-axis and the x-axis. We're going to have to allocate our variables to the two axes. Remember that we are controlling time, so your days are going to be on the x-axis. The thing that we are measuring is the height of the seedlings, and you're going to look and see your smallest height was 2, your greatest height is 78, so let's start with 2 and let's go up to 80 and let's decide, are we going to do these 2, 4, 6, or are we going to say that our smallest value is going to be 5, 10, 15? What you're doing is you're determining a scale for your axis. It was very easy to determine the scale for the x-axis. It was 1, 2, 3, right, the days. But now we have to make a scale for the y-axis that goes up in equal increments or in equal gaps. Remember also that we're looking at two sets of data. So on our one graph, we're going to have two different sets of axes, two different lines growing. So I think it would be best to use two different colors. And as you can see, mine here is rather messy. So let me show you the graph that I did when I had a proper ruler and a proper pencil and different colors, and I could measure everything out perfectly, just like you have in the test. So here is my final graph. I have a heading, and my heading shows me both of the variables, the height of the seedlings and the various days. I'm showing on my y-axis height of seedling, average height, and millimeters, and my days are just simply numbered along the x-axis. I'm also going to give an indication of a key. I'm going to show that pot A is going to be the green graph and pot B is going to be my blue graph. And of course, I plotted the points by going to the data table. So let's see how I would have plotted, for example, day 5's data. For pot A, at day 5, I go up at 5, and I have to see that my seedling height is 20. I would measure along and I would plot my point. What would be happening in terms of pot B on day 5? I would plot my point at just over 40 because my B seedling average was 42 millimeters. I would join my lines nice and smoothly and I would have drawn my graph. Heading, axes labeled, a good scale on the axis, points plotted accurately, and of course then the line drawn nice and smoothly, and there is my graph. Now I need to look further and see what questions am I going to be asked that are going to assist me in interpreting and analyzing this data. So drawing the graph is just the beginning. Let's take a little bit of a break. Let's look at this graph carefully when we come back after the break and make sure that we can analyze the data perfectly.